So just set the recording going. And so the key fact today for connected rates of change, the thing that's going to get us through it, is knowing this here. So basically this is very connected to parametric equations as well. So dy by dx is equal to anything at all with a dy on the top and a dx on the bottom, with the gap in the fraction filled with any other variable, like that, because the dt's cancel to give dy by dx. So very much the theory behind parametric equations, i.e. one differential can be indirectly calculated as a product of two others. And that there is the key idea behind today's lesson. So I'll show you what I mean by that. Let's get straight on to an example. So I'll put that example up there. And if you want to copy it down, if you're making notes, give you a little while to do that. But basically says the radius of a circle is increasing at a constant rate of 0.2 centimeters per second. Show that the perimeter of the circle is increasing at a rate of 0.4 pi centimeters per second. So the key here is to get all the information down that the question's given you on your first read through. So the radius of a circle is increasing at a constant rate of 0.2 centimeters per second. That tells me, so I'm going to use r as the radius. That tells me that dr by dt, the rate of change with respect to time, dr by dt equals 0.2 is what that tells me. So now show that the perimeter of the circle, so good practice here now is to write down the formula for perimeter. So as soon as we see something mentioned, write formula. So perimeter is 2 pi r of a circle, sometimes called circumference as well. So show that the perimeter of the circle is increasing at a rate. So we want the rate of change of perimeter. So this has told us that we want a differential involving perimeter. We want dp by dt is what the question's asking us for. Now we can't find it directly, so we'll go back up to this idea here. We make a formula involving two other differentials. So as to indirectly calculate dp by dt. So we know that for this to work, one's going to have a dp on the top and the other's going to have a dt on the bottom. And we want two things the same that are going to cancel, and those will be formed from the variable that we haven't yet mentioned in this differential, which is r. There's this letter r floating around that's going to get involved, so dr. So make the product of two differentials, put dp on the top, dt on the bottom, fill the gaps with a letter we haven't yet mentioned, dr. And notice with this here, we've actually already got one of these quantities, dr by dt. It's there. So it's dp by dr we need to find. Well, luckily, because we've done it this way and written down all the information as it was mentioned, we've got an equation linking p and r that we can differentiate to find dp by dr, which means that dp by dr equals 2 pi. Therefore, dp by dt, so we've got dp by dr is 2 pi times dr by dt, which is 0.2, equals 0.4 pi centimeters per second as required. So remember the steps we went through, write down all the information as it appears, find out what differential it's wanting us to find. In this case it wants us to find dp by dt. Form the product of two differentials, filling the gaps with the third letter not yet mentioned, then basically just go in for the kill. So part B will give us a chance to do that again. So find the rate at which the area, okay, what we need now, the rate at which the area. So before I've read the rest of the question, I'm writing down exactly what I need to find. The rate at which the area of the circle is increasing when the radius is 10. So I'm giving some extra information, r equals 10. So I'm not going to be able to find, I haven't got a formula connecting A and T. So what I'm going to have to find is this differential indirectly by timesing together two differentials, one with a dA on the top, one with a dt on the bottom, and fill with the letter we haven't yet mentioned. That's going to cancel. Also, before we get into anything else, we know a formula that connects A and R, pi r squared. So remember from before we've got dr by dt. You take a moment to find dA by dr. And this question requires a bit extra information, that r equals 10. Have half a minute to do that. So dA by dr equals 2 pi r. So let's find the formula. So dA by dt equals dA by dr, 2 pi r, times dr by dt, which is 0.2, equals 0.4 pi r. But that's not a number. We're given the extra information that that r equals 10. Since r equals 10, lowercase r, this implies that dA by dt equals 0.4 pi times 10 equals 4 pi centimeters squared per second. Then part C, find the radius of the circle when the area is increasing at a rate of 20 centimeters per second. or we can use our differential from part A. We know that it's told us that the rate of change of area equals 20 centimeters squared per second. We have a formula for the rate of change here. So that implies that 20 equals 0.4 pi r divided by 0.4 pi. So 20 divided by 0.4 equals 50. So 50 over pi equals r, given the units. Units probably aren't important in this, but we should give them anyway because it's a good habit to get into for mechanics. Let's try another. Remember, the key is writing down all the information you're given as it appears. So try to get in that habit here. Have a go at that yourself. Take a minute. There's a key word used in here, suggesting the question's trying to catch you out a little bit. So the area of a circle, stop reading, write down something that's bound to be useful, is decreasing at a constant rate, decreasing. So the area of a circle, dA by dt, is decreasing at a constant rate of 0.5. Decrease suggests that doesn't suggest, tells us that the rate of change is negative. Find the rate at which the radius of the circle, stop reading, so we need dr by dt, is decreasing when the radius is 8 centimeters. All about writing down the information as it appears. So we need to find dr by dt, but we can't do it directly. We need to do it indirectly as the product of two differentials, one with dr on the top, one with dt on the bottom. And what fills the gaps, the bit that cancels, is the variable we haven't yet mentioned, which is area. So we need dr by dA, but we haven't got r in terms of a. We've got a in terms of r, so what we could do is rearrange that to say r equals, but that would be incredibly wasteful. What we can find instead is dA by dr, the reciprocal of which is dr by dA. So dA by dr is 2 pi r, which means that dr by dA equals 1 over 2 pi r. So now we've got both of the things that we need. We've got dr by dA and we've got dA by dt. Therefore, dr by dt equals dr by dA 1 over 2 pi r times dA by dt, which is minus 0.5. dr by dt equals minus 0.5 over 2 pi, and we know that r is 8. Minus 0.5, minus 0.5. If you've got any questions, by the way, please do type them in the chat. Minus 0.5 divided by 2 times 8. We'll keep pi out of it for now, otherwise we'll just get in an irrational number. Equals minus 1 over 32 pi. So, normally in the past I've said that it doesn't matter whether the answer is positive or negative. It's asked for the rate of decrease. So technically speaking, the rate of decrease is 1 over 32 pi. But in all the mark schemes I've seen in the past, it's given the mark for a positive or negative answer. Now, I've seen one mark scheme recently which has penalised students for not discarding the negative sign. So I've sort of changed my opinion now on whether it matters to be plus or minus. So what I'm going to do is just, in a question like this where it's ambiguous, I'll leave my numerical answer as a minus, just in case it gets marks. Let's not forget the units actually. So dr by dt, the unit would be centimetres per second. And I'm just going to conclude with a sentence. The rate of decrease is 1 over 32 pi centimetres per second. And that just covers both bases. If they wanted the answer to be negative, we've got it there. And then we've interpreted it practically. So we're being ultra safe, trying to get all the marks. Let's try another, part B. Find the rate at which the perimeter of the circle, so perimeter is 2 pi r, and the rate that we need, dp by dt, and we're told again that r equals 8. So dp by dt we can form with using a differential with dp on the top, dt on the bottom, and the variable we haven't yet mentioned we can fill the gaps with. So dp by dr we need, which is 2 pi. dr by dt we've got from the beginning of the question, or have we? No, we haven't. We've got dr by dt when r equals 8 from the previous question here. dr by dt was negative 1 over 32 pi. Which means that dp by dt equals dp by dr, 2 pi, times dr by dt, which was negative 1 over 32 pi, equals, well, the pi's cancel, 2 over 32, negative 1 over 16 centimetres per second. And that's for the rate at which the perimeter is decreasing. So let's be ultra safe. The perimeter is decreasing at a rate of 1/16 centimeters per second. I think we're ready to go on to some exam questions. Let's have a look at some exam questions. If you've got any questions, as I say, in the meantime, do ask them on the chat. I'll address anything you want to address. So give me a moment to get these questions ready. So these are just from the exam questions on my website. So this first one was from a 2007 paper. There we go. So given that x is 4t plus 9 to the half, and y is 6e to the half x plus 1, find expressions for dx by dt and dy by dx. Have a go at that. The chain rule will be needed for this question. So, something to the power of a half integrates to a half something to the minus 1/2 times the differential of the bracket, which is 4, equals 2 lots of 4t plus 9 to the minus 1/2. dy by dx equals, differentiate e and you just get itself, times the differential of the bracket, equals 3 e to the half x plus 1, like that. So done that bit. Part 2, hence find the value of dy by dt. Well, we can't find it indirectly because we haven't got y in terms of t. I suppose we could find it, but that would be wasteful because we can take a shortcut using this new method that we found. We want dy by dt, and we know that that can be obtained by multiplying two things together, one with dy on the top, the other with dt on the bottom, and the variable we haven't mentioned yet is the one that cancels. So luckily they are the right way around for us. We don't have to do any reciprocals. So that's equal to dy by dx, which we worked out to be 2 4t plus 9 to the minus 1/2 times 3 e to the half x plus 1. Now there's a problem here because we're told t equals 4, which is brilliant for subbing in there, but we're not told what x is equal to. However, we can find what x is equal to when t equals 4 by subbing it in there. So t equals 4 implies x equals 4 lots of 4 plus 9 square rooted, square root of 25, which is 5. And this means that dy by dt equals 2 lots, 4 lots of 4 plus 9 to the minus 1/2 times 3e to the half. We found that to be 5 plus 1. And it wants the answer to 3 significant figures. So that's approximately equal to, then just put in the calculator, 2 lots of 4 times 4 plus 9 to the power of minus 1/2 times 3 e to the power of 1/2 of 5 plus 1, like that. And as for 3 significant figures, 39.7. Which, checking the mark scheme, is correct. We'll do another, and we'll keep on going like this. We'll keep on doing questions like this to familiarise ourselves. Right, Earth has been added to a pile so that when the height of the pile is h meters, its volume v is v cubic meters, where v is that formula there. Find the value of dv by dh when h equals 2. I think you can do that. So dv by dh, so differentiating that bracket, it's 1/2 times whatever's in the bracket to the power of minus 1/2, and the take 4 differentiates to 0, times the differential of the bracket, which is 6h to the 5. So at h equals 2, this implies don't know if you can all see that, but that's quite funny, that. Geography year olds thought the tsunami could flip an island upside down. I like that. So, at h equal 2, this means that dv by dh equals 1/2 2 to the 6 plus 16 to the minus 1/2 times 6 lots of 2 to the power of 5. A half of 2 to the power of 6. Notice I always put brackets around things I'm subbing in when I'm writing it down, just to remind myself to check whether it's positive or negative. Minus 1/2 times 6 lots of 2 to the power of 5, which is 10.73. Yeah, 10.73. I'll do a few more significant figures actually, just in case I have to use that number later on. 7331. Right, part 2. I'm seeing a lot of in the chat, a lot of geography mishaps. People used to think that water flowed up a mountain, and somebody thought Scotland was in Asia. Yeah, okay. So the volume of the pile is increasing at a constant rate of 8 cubic metres per hour. dV by dt, the volume is increasing at a rate of 8 cubic metres per hour. Find the rate at which the height of the pile, dH by dt, is increasing at the instant when h equals 2. Well, I can see that h equals 2 in our previous example, so that suggests that what we worked out in part 1 is going to be useful. So dH by dt we can get by multiplying two differentials together, one with dH on the top, one with dt on the bottom, and the third variable I haven't mentioned yet is the one we're going to use to cancel. So dH by dV, well, we've got dV by dH, so dH by dV is just the reciprocal of that, 1 over 10.7331 times by dV by dt, which we worked out to be 8, equals, and I've just noticed I forgot to put the unit in my previous answer. So what was the unit for, what was it we're trying to find? dV by dH would be meters, cubic meters per it doesn't actually seem appropriate to put the unit there because one's cubic meters, the other's meters. The units I've got to cancel. I'm going to retract that claim. I'm going to stay well clear of the units on that one. One over 10.7331 times 8 is 0.7, how many significant figures? 2, 0.75. Although it's safer to put the unit here. Meters cubed per hour. We'll do another. We'll keep going like this. So take a look at that one there. Back to the wordier ones. Oh yeah, you're quite right. The unit is meters per hour. I was looking at this here when I wrote that, but yeah, quite right. Correct it to meters per hour. Yes, because it was actually dH by dt we were finding. Thank you for that. Leaking oil is forming a circular patch on the surface of the sea. The area, okay, area of a circle, A equals pi r squared, is probably going to be useful. Write down everything you might need as it appears. Is increasing at a rate, the area of the patch is increasing at a rate, which is dA by dt, of 250 square meters per hour. Find the rate at which the radius of the patch is increasing at the instant when the area of the patch is 1900. Well, dr by dt we can find by multiplying two differentials together, one with dr on the top, one with dt on the bottom, and the third variable being the one that cancels, that fills the gaps. We've got dA by dt, that was given in the question. So it's dr by dA we need to find, which usually we find by differentiating an expression there. But notice we're going to get dA by dr here, not dr by dA. Let's go with it for now. dA by dr is 2 pi r, which means that dr by dA is equal to 1 over 2 pi r. Which means that dr by dt equals dr by dA times dA by dt, which was 250, but notice we haven't got the value of r. However, we can find it. We've got the area, so from that we can find the radius. So 1900 equals pi r squared, which means that r equals the root of 1900 over pi which is 24.592. Which means that dr by dt equals 1 over 2 pi times 24.592 times 250 equals, let's put it in the calculator. So the key to getting good at this topic is just to do loads and loads of examples. Equals, and it wanted it to two significant figures, so 1.6. Let's try and get the units. So radius was meters per hour. And another. So you start to see that these are quickly doable. There's another there. A giant spherical balloon has been inflated in a theme park. The radius of the balloon is increasing at a rate of 12 centimeters per hour. The radius, 12 centimeters per hour. Find the rate at which the surface area of the balloon, dA by dt, is increasing at the instant when the radius is 150. Give you answer in centimeters squared per hour, correct to two significant figures. So dA by dt is equal to any differential with dA on the top, dt on the bottom, with the gap filled with a third variable that's mentioned in the question. So I can see we've got dr by dt, but we haven't got dA by dr, and luckily it gives us in the question the surface area of a sphere, so there's the formula we're going to use. So the surface area A equals 4 pi r squared, which means that dA by dr equals 8 pi r. I'll give you a moment to get that finished. Which means that what we were asked to find, which was dA by dt, equals dA by dr, 8 pi r, times dr by dt times 12. And we know that the radius is 150, so 8 pi 150 times 12 which is equal to that. And let's just see, correct two significant figures, so 45,000. Centimeters squared per hour. One last question that we'll do today. Quite controversial on the day, on the actual exam it appeared on, because you were fooled into thinking there wasn't enough information. The diagram shows a container in the form of a right circular cone. The angle between the axis and the slant height is alpha, where alpha is arctan of a half. Initially the container is empty, and then liquid is added at the rate of 14 centimeters cubed per minute. The depth of the liquid in the container at time t is x centimeters. Show that the volume v centimeters cubed of liquid in the container when the depth is x centimeters is given by that. So 12th pi x cubed. Now this is the key here. Arctan of a half. Alpha is arctan of a half. That means that tan alpha equals a half. i.e. opposite over adjacent is a half. So the ratio of that side to that side, 1/2, a half. So if that one is x, then that must be 1/2 x. And that unlocks the ability to do this part 1. So part 1, the radius equals 1/2 x. Since opposite over adjacent is a half, then the rest of it's doable. I'll give you a moment to do this and the next part, then I'll go through it. So the volume is a third pi r squared times h, which indeed is a 12th pi x cubed. Part 2. Find the rate at which the depth of the liquid, the depth is x, so we need dx by dt, is increasing at the instant when the depth x is 8. So if we need dx by dt, we're going to have to find that indirectly. Dx on top, dt on the bottom, and the variable we haven't yet mentioned, the volume, is what we need. So one thing that I failed to do originally is get that information down. Liquid is added, so the volume changes at a rate of 14 centimeters cubed per hour. So we've got dV by dt, we just need dx by dV. Well, we can find dV by dx because v equals, as we worked out in the previous part, a 12 pi x cubed, which means dV by dx equals a quarter pi x squared. Which means that dx by dv is the reciprocal of that, 4 over pi x squared. Therefore, our dx by dt is equal to, so dx by dv, 4 over pi, and we know that x is equal to, it's told us, 8 times dv by dt, which you gain from the question to be 14. So 4 over pi times 8. Should write the squared on there as well, sorry. Yeah. Pi times 8 squared times 14. Which is equal to 0 point, and it wanted to 2 decimal places, so 0.28. And it's centimeters per minute. I forgot to write the 0 point there. There we go. Right. That's it. We're done. A few minutes early, but got through all the examples I wanted to. So I think the worksheet in the lesson area is a good one to go through. The connected rates of change one, and have a go at some more of those exam questions from my website. But hope you found that useful anyway.